A journey through time, the allure of the unknown. The concept of time travel has captivated the human imagination for centuries. The ability to journey through time, to witness historical events, or to glimpse the future, holds an irresistible allure. It speaks to our deepest desires to undo past mistakes, to experience the unknown, and to understand our place within the grand tapestry of time. But is time travel merely a fantastical notion confined to the realms of science fiction, or could it one day become a reality? Defining time travel. A leap into the fourth dimension. Time travel, in its simplest form, refers to the ability to move forward or backward through time. Just as we can move through the three dimensions of space, length, width, and height, time travel would involve navigating the fourth dimension, time itself. While we constantly travel through time at the rate of 1 second per second, true time travel would involve manipulating this flow, either accelerating, reversing, or jumping to specific points in time. Time travel in popular culture, from H.G. Wells to Back to the Future. The concept of time travel has been a recurring theme in literature and film, capturing our imaginations and sparking debate about its possibilities. H.G. Wells's groundbreaking novel, published in 1895, introduced the concept of a device capable of transporting its occupant through time. Since then, countless stories, from the classic film to the intricate narratives of, have explored the potential consequences and paradoxes of time travel. These fictional portrayals, while entertaining, often take creative liberties with the science of time travel. Understanding the true possibilities requires delving into the realm of modern physics, particularly Einstein's theory of relativity. Einstein's relativity, bending time and space. Albert Einstein's theory of relativity, published in the early 20th century, revolutionized our understanding of space and time. Einstein proposed that space and time are not separate entities, but are interwoven into a single fabric called space-time. This fabric, according to Einstein, is not static, but can be warped and distorted by massive objects, such as stars and black holes. One of the most intriguing predictions of Einstein's theory is that time is not absolute, but is relative to the observer's frame of reference. This means that time can pass at different rates depending on factors such as speed and gravitational pull. Wormholes, tunnels through the fabric of space-time. One theoretical concept that has emerged from Einstein's relativity is the possibility of wormholes. These hypothetical objects are essentially shortcuts through space-time, connecting two distant points in the universe. Imagine folding a piece of paper in half and poking a hole through it. The hole would represent a wormhole, allowing you to travel instantly between the 2 points on the paper. While wormholes are theoretically possible within the framework of Einstein's equations, their existence remains purely hypothetical. Even if they do exist, the technology required to create and stabilize a wormhole for time travel is far beyond our current capabilities. Time dilation, a one-way ticket to the future. One fascinating aspect of Einstein's theory of relativity that has been experimentally verified is the concept of time dilation. This phenomenon has intrigued scientists and laypeople alike for decades. Time dilation occurs when time passes at different rates for observers in different frames of reference. This means that two people can experience time differently depending on their relative motion or position in a gravitational field. This can happen due to differences in speed or gravitational pull. For instance, the faster you move, the slower time will pass for you compared to someone who is stationary. For example, time slows down for objects moving at high speeds relative to a stationary observer. This effect has been observed in high-speed jets and even race cars, though the differences are minuscule at these speeds. However, the effect becomes much more pronounced at speeds approaching the speed of light. This means that if you were to travel in a spaceship at a significant fraction of the speed of light, time would pass considerably slower for you than it would for someone back on Earth. Upon your return, you would have aged less than those who remained on Earth, effectively traveling into the future. This is not just science fiction, it's a real consequence of the laws of physics. While this form of time travel is theoretically possible, it only allows for travel into the future, not the past. The idea of traveling back in time remains in the realm of science fiction and theoretical speculation. Moreover, achieving the speeds necessary for significant time dilation would require immense amounts of energy and advanced technology. Current technology is far from making this a reality, but the concept continues to inspire scientific research and imagination. The perils of the past. Paradoxes and impossibilities. While traveling to the future, though challenging, might be within the realm of possibility, traveling to the past presents a whole new set of challenges and paradoxes. The future is an open book, a realm of endless possibilities, but the past is a closed chapter, bound by the events that have already occurred. One of the most famous is the grandfather paradox, which highlights the logical inconsistencies that can arise from time travel to the past. This paradox is a staple in discussions about the feasibility of time travel, and has been a subject of fascination for both scientists and science fiction writers alike. The grandfather paradox posits that if you were to travel back in time and kill your grandfather before your parent was born, you would prevent your own existence. This scenario creates a ripple effect, questioning the very fabric of reality and causality. This creates a logical contradiction, as you couldn't exist to travel back in time if you were never born in the first place. The paradox challenges our understanding of cause and effect, making us ponder the true nature of time. Such paradoxes raise serious questions about the consistency and stability of space-time and suggest that travel to the past might be inherently impossible. They force us to reconsider the laws of physics and the limitations of our universe, pushing the boundaries of what we believe to be possible. The multiverse, a solution to time travel's paradoxes? One way physicists have attempted to resolve the paradoxes of time travel is through the concept of the multiverse. The multiverse theory proposes that our universe is just one of an infinite number of parallel universes, each with its own unique timeline and set of physical laws. According to this theory, traveling to the past wouldn't alter your original timeline but would instead transport you to a parallel universe with a similar but distinct history. In this way, you could theoretically interact with the past without creating paradoxes in your original timeline. However, the concept of the multiverse, while intriguing, remains highly speculative and lacks any direct experimental evidence. Time loops and causality violations, untangling the threads of time. Another challenge posed by time travel is the potential for causality violations, which can create paradoxes and disrupt the natural order of events. Causality refers to the relationship between cause and effect, where an effect cannot precede its cause. This principle is fundamental to our understanding of the universe. Time travel to the past has the potential to disrupt this fundamental principle, leading to logical inconsistencies and paradoxes that challenge our perception of reality. For example, imagine you travel back in time and give yourself the plans for a groundbreaking invention. This act could create a loop with no clear origin. You then go on to create the invention in the present, having received the plans from your future self. This creates a paradoxical situation. This scenario creates a closed loop, where the origin of the invention becomes unclear. Did you create it, or did your future self provide the knowledge? The lines between cause and effect blur. Such causality violations raise profound questions about the nature of time and free will. They challenge our understanding of how events unfold and whether we have control over our destinies. If the future can influence the past, does it mean our choices are predetermined, or do we have the ability to alter the course of events? These questions remain at the heart of the mystery of time travel. Time travel, science fiction, or future reality? The possibility of time travel continues to fascinate and elude us. While Einstein's theory of relativity provides a theoretical framework for understanding how time travel might be possible, the practical challenges and paradoxes remain daunting. Currently, time travel exists primarily within the realm of science fiction. While we have observed time dilation at extremely small scales, the technology required to manipulate time in a meaningful way for humans is far beyond our current capabilities. However, as our understanding of the universe continues to evolve, it's possible that new discoveries and technological advancements might one day unlock the secrets of time travel. Until then, it remains a tantalizing possibility, a testament to the boundless potential of human curiosity and our fascination with the unknown.